Now let's talk about vectors and vector additions. So a vector is a quantity that has magnitude and direction drawn as a ray. So for example, here's the ray, that's a vector, how vector is represented. The length of this ray represents its displacement, the magnitude. Obviously, we need to use the scale to determine its magnitude. For example, this is about 2 centimeters. We can say 1 centimeter is 50 meters. Then the 2 centimeter would be equals to 100 meters. If 1 centimeter is 5 meters, then 2 centimeters would be 10 meters. So to determine the magnitude, you'll have to use the given scale. The direction is represented by the direction of the arrow. Let's take a look of vectors. So handwritten note is a letter with an arrow on top to indicate that quantity is a vector, and this arrow represents the vector. This is called a tail, and this arrow, that's called a head. This is where you start, this is where you end. We can call that displacement vector. Sometimes it can be a velocity vector, or acceleration vector, or force vector, or momentum vector, and so forth. The displacement depends on only the starting and ending position, not the path. So there are 1,000 ways or 1,000,000 ways to go from point 1 to point 2. But it doesn't matter which way you go, you ended up in the same place. From point 1, point 2, there is only one vector, one displacement. It could be many, many, many distances. It depends on the path. If an object moves around, or take a round trip, the total displacement is 0. So regardless the distance, you could travel 1,000 miles, the total displacement is still 0. Equal and inverse vectors. The vectors are the same if they are the same size and they are pointing in the same direction, obviously with the same scale. Right, these two vectors is the same. And P5 and P6, this is opposite of vector A because it has the same size but in the opposite direction. We call that anti-A. That's inverse of A. Vector additions, we learned last year, we can add them from tip to tail. So we already know what's the tip. Tip is the arrowhead, the tail is the other end. We just simply draw one followed by the other. Then we draw for the resultant. You have to go from where you start, from the tail of the first one to the tip of the last one. That's how you find the resultant. As you can see, it doesn't matter which one goes first, the resultant is the same. You can also add them by constructing a parallelogram. To construct a parallelogram, you have to do tail to tail and draw the two parallel sides. This diagonal of the parallelogram from the tails of both vectors to the other end, that is the resultant. So this is a vector not just pointing to any direction. It's just not anything from tail to tail. It has to pointing to the direction that's along the diagonal of your parallelogram. Here is how you add two vectors going to the same direction. That's called the two parallel vectors, from the beginning of the first one to the end of the last one. So you get a bigger vector. Here is how you add two anti-parallel vectors. Anti-parallel means they are pointing to the opposite direction from the beginning of the first vector to the end of the last vector. So this is C equals to A plus B. Commutative properties of vector addition, that means the order you add them doesn't matter. So A plus B plus C, add AB together first, or you can add BC together, then add to A. So the order doesn't really matter. Resultant and equilibrant. So they are related. They have the same magnitude. For resultant, tip to tail, we know R is the resultant and opposite of R. This is E called equilibrant. So E is anti-R. Anti-resultant, that's equilibrant. So this E can cancel out a plus b. So if you add a, b, and e, you get 0. It's kind of going in a circle, right? A, b, and e, that's become 0. The resultant of 3 vectors is 0. You can also find e through parallelogram. Take a look. If you have tail and tail together, here's A is red, B is blue. You add together. This R is the diagonal pointing away from the tail. That's your resultant. Pointing toward the tail, that is your resultant. That is your anti or equilibrant. So remember, R and E are always in the opposite direction, along the same diagonal in the opposite direction. Subtract vectors. We can subtract vectors by adding a negative vector. A plus B is just A minus B is just A plus negative B. So how do you, A and B together, how do you add it? So you draw A first, then you draw negative B. Here is B going in this direction, negative B would be here. So this vector from the beginning of A to the end of B, that's A minus B. We can also subtract using parallelogram. So when you have tail and tail together, here is tail and tail together. How do you find A minus B? That's C. First, we know A plus B is this diagonal, right? And negative A minus B, this is negative. This is called equilibrant. It's going the same diagonal, but going the other way. That's the one diagonal of your parallelogram. The other diagonal, if it's pointing to A, that's A minus B. If it's pointing to A minus B points to A. When you have parallelogram with tail and tail together, A minus B, that's the other diagonal. When it points to B, that's B minus A. We know these two are opposite anti-vectors, right? A minus B is negative B minus A, right? And they are in the opposite direction, have the same magnitude. Let's take a look at this example. This one says, at time t1, you'll have v1. At time t2, you'll have v2. What is the acceleration? According to the definition, acceleration is v2 minus v1 divided by time interval. So this is a vector difference. This is subtraction of vectors, v2 minus v1. So we can add a negative vector. Add a negative vector v2 plus negative v1, and this is what we have, is the v2 minus v1, which should have the same direction as acceleration. So that will give us C. Or we can use parallelogram. If you connect both at tail to tail, remember v2 minus v1 has to point into v2, so it would go this way. As you can see, these two are the same, right? So the answer is C, either way. Another example, same question. So what is the direction of acceleration? Here is v1, here is v2. Vector subtraction, right? So you can use add a negative v2, add a negative v1, or you use parallelogram. So here is v2 plus negative v1, then this direction, this is v2 minus v1. Or you can use parallelogram, you will have the same answer. Here is another one to how to add it, how to add and find the directions when you have two vectors that's perpendicular to each other. In this case, we can use Pythagorean theorem. We can use the inverse tangent to find the direction. Pythagorean theorem to find the resultant, inverse tangent to find the direction. And the direction would be this angle. Remember, how do we find the angle? This would be east of north. You're going from north to the east. So it's east of north because this angle is measured from north. So it's of north. Which direction do you go? Of north, you can go to west or east. You want to east. So it's east of north. Okay, another example. Match the following vectors from the given diagram with the answers 1, 2, 3, or 4. So this is A plus B. A plus B, tail and tail, we can use parallelogram, right? So this one would be A plus B. the one in the middle is a plus b, so that's number 1. A plus b is number 1. What's number 2 is opposite of 1. Opposite of 1 is negative a minus b. So this one, C, would be 2. A minus b. A minus b, remember, is the other diagonal. A minus b has to point into A. So number 3 has to be A minus b. B minus A is anti-A minus B, or opposite of A minus B. So B minus A has to be number 4. Okay? So we have 1, 2, 3, 4. Another one. In terms of vectors A, B, what is vector C? Vector C, if you draw a parallelogram, vector C is the other diagonal. It's pointing to B, so it has to subtract. It's B minus A. Another way, draw a parallelogram. Remember this diagonal? That's A plus B. The opposite is negative A minus B. The other diagonal is subtraction. And if it's pointing to A, it's A minus B. If it's pointing to B, it's B minus A. So the answer is B minus A. Last one, check your understanding. So you have two vectors, size 3 and 4. Which of the following could be have the magnitude of the difference? Or addition, S minus T or S plus T can be in the same range. So the range is, you add the two together, you have maximum of 7 and a minimum of 1. So S minus T or S plus T can have a maximum value of 7 and a minimum value of 1, can range anything between 1 to 7. So here's 1, 5, and 7. All the others are out of range. So can only be that. And that's it. Thanks for watching.